In this video, we're going to be looking at finding zeros from an equation, including looking at multiplicities of zeros. In problem 1, I'm asked to find the zeros of this polynomial function. So when I'm asked to find the zeros, that means the function value f of x is going to be 0. So I have this equation. So this is similar to a factoring problem that we used in working with quadratic equations. The only way that I can multiply numbers together and get 0 for an answer is if one of my numbers is 0. So I'm going to set each of my factors equal to 0 and solve. So these are my zeros. Now, one thing I do want to point out is when I said I wanted to set each of my factors equal to 0, this -3 is a factor, but I don't set it equal to 0 because it doesn't have a variable there. Problem 2 says to use the equation to solve for x when f of x is equal to 0, that is, find the zeros. I want you to be sure that you understand there's several different ways that you can basically be asking the same question. So you really need to be sure that you understand the vocabulary and really what's going on with the relationships between the different representations of zeros and factors. So this is the equation I'm asked to solve. And again, I'm going to solve that by setting each of my factors equal to 0. And those are my solutions. Next, we're going to be talking about multiplicities. The multiplicity of a zero is the number of times its corresponding factor occurs. The directions say to determine all the zeros and their multiplicities, hint, be sure to factor completely. And with problem 3 here, this is not factored completely. X squared minus 25 is a difference of perfect squares, so that can be factored. Okay, so this is factored completely. And I want to point out that at the beginning of this problem, I rewrote those first two factors to where the 6 was in parentheses and my x was inside the parentheses and my exponent outside the parentheses. So now I can easily set each of my factors equal to 0 and solve. Okay, so there are my zeros. Now I'm not quite done yet. I'm also asked to state the multiplicities. And the multiplicities is the number of times each factor occurs. So basically you're just looking at the exponents. So I have this exponent and this exponent that I really need to worry about. All of the other factors have a multiplicity of 1, and you don't really need to write that out. So I'm going to say that x equals 0, so this has a multiplicity of 2. We're going to abbreviate multiplicity because our book does. X minus 7 occurs as a factor 2 times, so 7 has a multiplicity of 2. This problem is already factored completely, so I just need to set each of my factors equal to 0 and solve. Now, the first factor is fairly easy to solve for. The second factor of x squared plus 16, I'm going to solve by isolating my variable. Take the square root of both sides. So I get positive and negative 4i. I'm going to write that out as two separate answers, 4i and negative 4i. In my first factor, I had an exponent of 3. So 5/4 has a multiplicity of 3. My second factor of x squared plus 16 only had a multiplicity of 1, so I really don't need to write anything out for that. This is already factored completely, so I'm going to set each of my factors equal to 0. and then solve. My first factor of 2x plus 3 quantity cubed means that I'm going to have a multiplicity of 3. And the 6i and negative 6i both have a multiplicity of 5. Problem 6. Write a polynomial f of x in complete factored form that satisfies the conditions. Let the leading coefficient be 1. The degree is 5. And my zeros are negative 6, the multiplicity of 4, and 4 with the multiplicity of 1. I know my zeros are negative 6 and 4, so that means my factors are x plus 6 and x minus 4. So my function is going to be some constant a times x plus 6 with a multiplicity of 4, so that means I have an exponent of 4 here. X minus 4 is a factor, and that has a multiplicity of 1. Now, if I have 4 factors here and 1 factor here, altogether I've got 5 factors, 5 zeros, and because my degree is 5, I know that that's correct. I'm told that my leading coefficient is supposed to be 1, so that means a is 1. I don't really need to write 1 there. It's understood to be 1. Just like on this last factor, I don't need that exponent of 1. So that's my answer. In this problem, I'm given 3 zeros of a function, and I'm asked to find the corresponding factors. So I'm going to start off by writing x equals and then my 0. And I'm going to try to get everything to one side of the equal sign. So on this first part, I'm going to add 7 to both sides of the equal sign. So I have x plus 7 equals 0. With my second 0, what I'm going to do is to get rid of the fraction, I'm going to multiply both sides of my equation by 3. So I get 3x equals 2, and then subtract 2 from both sides of my equation. So I have 3x minus 2 equals 0. And on my last 0, I'm subtracting 9 from both sides. So x minus 9 is equal to 0. So my corresponding factors are x plus 7, 3x minus 2, and x minus 9. Problem 8, the zeros of a polynomial function are given. Find the corresponding factors. So I'm going to start off by setting each of these zeros equal to x. I need to get everything to one side of the equal sign. So with this first factor, I'm going to add 2 to both sides. So I get x plus 2 to be 0. With my second x, I'm going to do this problem slightly different than I did the previous problem. In the previous problem, I started off by getting rid of my fractions, and then I moved my 0 over to the left-hand side. Here, I'm going to move the 5/4 over and then get rid of my fraction. And then I just wanted to show you that it doesn't really matter which order that you do that in. So I'm going to multiply both sides of my equation by 4. So that means that everything gets multiplied by 4. And there are my factors.